video is going to show you a little bit clearer how to use this page 10 of your reference tables, the inferred properties of the Earth's interior. So just to cover over some things up at the top here, just to be clear, that first you have here the crust and the rigid mantle. Together, those two lines make up the lithosphere. Okay, the crust is going to be this black line. The rigid mantle is going to be this lovely thin white line. And what separates the two spots is this dotted line over here called the moho. So the moho is what separates the crust and the rigid mantle from each other. Okay, so then we have the asthenosphere under that. That's that peanut buttery, frosting-like consistency, thick but liquid but not liquid, and solid but not solid kind of consistency. Okay, that's why they call it the plastic mantle, because it's able to move. Those convection currents are able to move through there. In fact, you can see convection currents going on right here. Okay, you also can look and see over here, they have where a trench can get subducted under, where the oceanic plate is running into a continental plate here. Excuse me. And then you also can see the densities. That at the surface of the Earth, the continental crust is 2.7 grams per centimeters cubed. And then you have the basaltic ocean crust, which is 3 grams per centimeter cubed. Okay, under that, where you have the asthenosphere down to the stiffer mantle, you're getting 3.4 to 5.6 as a density, and then you get to the outer core, it's between 9.9 and 12.12, and the inner core is going to be 12.8 to 13.1. So these are the densities going on over here. Now, dismiss. So that's the density, and then we had each one of the pieces of the interior part of the Earth. So I'm going to zoom out a little bit and show you I'm sorry, I have to turn this to vibrate because I'm getting notifications up the wazoo. So now you have the pressure piece of it. So we're going to do this one in orange. So what happens is I'm going to take my yellow. The stiffer mantle section will travel down through this whole part right here. So if I was to say at the bottom of the stiffer mantle, I want to know what the pressure is. So if you look, let's choose this. So if you look and you follow this solid black line, that is not the color I just chose, this is. You follow this solid black line down to the bottom of the stiffer mantle, it goes right about here. So if I follow this straight across to look, which that was not good, that was a bad solid line. Come on, Miss Baker, let's do a line. So if I line it up right here, and I can go straight across at my 90-degree angle, okay, I would see it's about 1.5 million atmospheres. Say that I did it here at the bottom of the outer core. I can actually follow it straight across, and it almost comes off to be around 3 million atmospheres of the amount of pressure that's pushing down as you go farther down to the center of the Earth, which again is why everything's dense up there. Okay, so that is pressure. Now, if I go down to the temperature piece of it, similar thing, just going to be different temperatures. If I go to the bottom of the stiffer mantle and I draw myself a line across here to show where the temperature is, the temperature at the bottom of the stiffer mantle is going to be about 5,000 degrees Celsius. Same thing if I was to go to right about here at the top of the stiffer mantle or bottom of the asthenosphere, that's going to be at about, I'd say about 2,500, 2,600 degrees Celsius. So that's how you read the temperature. Now, there are melting points. So if you notice here, there's this dotted black line, and then there's this dotted black line. Whenever the solid black line goes over the dotted black line, which is kind of in between in this inner or outer core part, that means that the temperature is hotter than the melting point. So that means that this section right here is going to be liquid, where then it falls under the dotted line here, which means that the inner core is solid, the outer core is liquid. If you look in the asthenosphere, remember we said it has that peanut buttery type consistency. That's because the melting point and the temperature are almost the same the entire distance through here. So that's why that's going to be that weird peanut buttery consistency, because the melting point and the temperature are almost about the same. Okay. The last thing that you pay attention to is the depth. So say I wanted to know how deep the beginning of the outer core is. I'll follow my black solid or dotted black line down, and it's just a little bit over 5,000 kilometers. So maybe 5,100, 5,050 kilometers deep, and so on and so forth. So if I look, the bottom of the asthenosphere is at about, I'd say about 700 kilometers deep. So that's how you would read those. Okay. Any questions on this? Just make sure you reach out and ask me. But this chart shouldn't be too bad in figuring stuff out. Let me erase all this stuff so that you can see what it looks like without it. So page 10 of your reference tables. Make sure you know how to use this.